Hello, everyone. We're going to quickly go over a couple examples of new types of state functions that come from these equations. You'll notice first we have the energy balance equation here in the difference form, which means that the energy at one time point in the future minus the energy at some previous time point is equal to the sum of all of these processes that are taking place. This includes the flows of energy into and out of the system, the energy by heat transfer, shaft work, pressure, volume work. We also have the entropy equation down below that has a balance similarly with this extra term we've been discussing called S-gen. And so we're going to start with these equations to then derive a new energy for a system that operates closed, isothermal, which means that T is constant, and also a constant volume. So if that's the case, what we're going to do is we're going to cheat here. We're going to copy and paste these equations and then cross a bunch of stuff out down below. So we'll do a quick copy, and then it's the magic of the iPad allows us to copy and paste it. So now we can go through, and what we care about is this change in energy and entropy in these two states with this type of system. So it's closed, so all of these terms with the mass flow are gone. Let's use red to strike through those. Now all the mass flows and entropy are gone. Similarly, we're not going to worry about changes in kinetic energy or potential energy for this system. We have no information to discuss it. And then it's a constant volume system, so this expanded work term that has energy will also go away because the volume at the beginning is the same as the volume at the end. In a minute, we'll go to a system with no S-gen, but we'll leave it in for now, just for now. Okay, so moving on. We eliminate those terms. What we have for our energy balance equation is U, I'm just going to use subscript 2 for U at T2 minus U1 equals Q plus WS, or rearranged, U2 equals U1 plus Q plus WS. Similarly, from the entropy balance equation, what we have left is S2 equals S1 plus the entropy generation caused by heat flow plus the S-gen term. The way that we combine these two equations to look at what kind of role entropy is having on our energy equation is through Q. So if we rearrange this for Q, and note that we're going to operate at 1T1 equals T2 equals T, we will have then Q equals S2 times T minus TS1 minus T S-gen. Okay, so if we take these terms away now, and we substitute them, now we take this and substitute it into our energy balance equation, we'll end up with the equation, if we rearrange for WS, is equal to U2 minus TS2 minus, in parentheses, U1 minus TS1 plus TS-gen. Now, if we consider this to be a reversible, which means the best possible conditions, so we have no small gradients in temperature, we have no entropy generation term, then we'll strike through this, and we're left with this WS equals U2 minus TS2 minus U1 minus TS1. And what this, because it appears regularly in these types of systems, it's been convenient to define this as a new thing called A2 and A1, where A is known as the Helmholtz free energy. And this is a free energy that's used in a number of systems where you have, again, constant mass, and closed, so there's no flows, constant V, and constant T for isothermal.